So now we'll be looking at variables. So now we've looked at uh, classification of variables. Now we can also classify variable based on their availability or visibility. Now, so now the two major classifications of variable based on their availability or visibility are we have one, the state variable, and two, we have the variable local variable. So now, what are state variables? What are local variables? Local variables are we can see local variables are variables that can be accessed globally, or we can regard them as global variable. So all these variables you are seeing here are simply regarded as what, as state variable. And the reason why we regard them as state variables is because these variables, they determine the state of the blockchain. So if they experience any change, the blockchain will need to update itself so as to reflect the changes that occurs in this variable. Then when we now talk about local variables are variables that are within a function, just like uint, let's say age, within a function, and store one. So these are example of what? These are example of local variables. Local variable are variables that are within a function, while state variable are variable that can be accessed globally. They are variable that are outside a function. And what I would like us to know is all the variables in this function are available just only with this function. Any attempt to to access this variable outside this function, then Solidity will throw an error that such variable is undefined, because variables in a function are regarded as local variable, and their what, and their scope to this function. That is, when I mean that their scope, that is, they are only available within a function. Now let's do a practical example. Let me create a variable name xyz is equal to 1. Then let me create another variable and say uint renew is equal to xyz. So what you see, Solidity is what, definitely throwing an error, undeclared what, identifier. So this variable inside this function, this variable xyz inside this addness function is not accessible from outside the function, but the state variables are accessible outside the function. Now let's access this active variable now. So now I can just create a new variable and say uint ax is equal to what, is equal to active, and so now I can access this variable outside this function, this active. Now for me to access it, uint a xyz xz is equal to active, save. So Solidity compiles without what, without throwing an error. Now let's move to storage locations, and let's look at storage location. Basically, in Solidity, we have we have about 6 or 7 storage locations, but the major the storage location we are interested in this tutorial are just basically three. We have the three storage location we are in. The three storage location we are interested in are one, the memory storage location, the memory storage location, the core data storage location, and we have the storage location. So now, why are we interested in this storage location? We are really actually interested in this storage location because it is really important for us to understand how the relationship with this storage location and variables type, just as the value type and the state, just as the value type and the reference type. Now we've looked at how to create a function. So now we've looked at various value type, so we've looked at various data types such as the value type and reference type. Now I really want to show us how these various data types behaves in a function. Now, for variables that are state variable, they are automatically what? For variables that are state variable, they are automatically stored in the storage location, and the storage location is stored data permanently. That is, when we mean storage location, that is, we are directly storing our data on the blockchain, and those data are stored permanently. Then when we talk about the memory data location, the memory data location stores the data temporarily. That is, the data that are stored in the memory storage location, they only exist within the life cycle of the function. That is, they early they that is, they exist during when a function is executing its code, and then they will no longer exist after a function is done executing its code. So but the data that are stored in this memory location can be modified. Then same thing too comes with the core data. So the data that are stored in this core data storage location, they are stored temporarily, but what happen is that we can't change them. We can't change the data that are stored there. So that is just the difference between the memory storage location and the core data storage location. Once a memory storage location store information temporarily, and the information that are stored in it can be modified. The core data storage location stores information temporarily also, but the data that are in it, they cannot be modified, while the storage location is stored data permanently. So now if we declare a variable as storage, if we declare a variable that they are storage variables, then the variable will directly be stored in a blockchain. And this type of variable, they are persistent. They are not stored temporarily, they are stored permanently. Now I want us to understand the relationship between this storage location and the various data types that we have. Now let's create a function. So we've created a function, and then, and as I said, the syntax for creating a function is the function keyword, then followed by your function name. Then let's just say practice. Let's just name our function practice. Then the visibility, which is what? Public visibility. And when we say function is public, that is, we are telling Solidity that this function will be allowed to be accessed both within this smart contract and outside this smart contract. Now let's look at the various data types. So now if we are using so now let's first look at the reference data types. So now let's start with the array. Now one important rule of Solidity, or one important rule Solidity give us, is that we cannot use a dynamic array. We cannot declare a dynamic array in Solidity functions. The only type of array that can be used in a Solidity function are fixed array. And don't forget, whatever variable that are declared in a function are known as what? Are known as local variables. No, now so now the way in which we create a array inside the function is we use our uint to tell Solidity the content of the array. Then we use our two brackets. Then we also specify the storage location where we want to store this particular array. Then we input what? We input memory. Then what will be our array name? Array of teachers. Array of teachers. Now we'll specify. So now when we are creating an array in Solidity, then syntax for creating it is we first write the data types, the content of what will be array, then a symbol to indicate that what we are creating is an array. Then now, so we are specifying a storage location. Then after a storage location, we then need to what? We then need to initialize this array. It is a must that we must initialize this array. So initializing this array will make this array what? A fixed array, because in Solidity, when we are the only array that are allowed to use in a function, and when a variable array is being used in a function, we are regarding that variable as what? As a local variable. So now, and in Solidity, the only array that are allowed is a fixed array. So now the syntax for creating this array is this. We will specify the type of variable in the array bracket, which tells Solidity that what we are creating is an array. Then the storage location, it is a must to specify the storage location. Then you now need to make this array a fixed array now, because that is what Solidity tell us. The array must be a fixed array. Then to now make the array a fixed array, then we make use of the new keyword. Then after the new keyword, we specify the data type. So it must correspond to what we have here. So it must be both uint. Then after specifying the data type, then you write your array again. Then this time we put a what? A two bracket. Then what number of items should the array be? Then four. So we have successfully been able to create an array in a function. Now, let's now look at same thing too applies to struct. So now we created a struct previously, a struct name student names. Now, if we want to create a struct within an array, you specify the struct on the struct, and then you put the struct name. And then after inputting the struct name, don't forget to specify what? Storage location. So we are choosing what? We are choosing memory. We are choosing memory. Then let's now create our struct object. I don't know what just happened. Okay. Let's now create our struct object. Let me input a semicolon. Input a semicolon here to avoid some errors. Then now to create our struct object. Then so the first one there is name and age. So name and age, then input your name, hey Steve, and our age is what? 12. Then remove this semicolon that is causing an error here. Compile your code. Everything compiles successfully without throwing an error. So one last thing for us to know is that for mapping, we can create a mapping in a function. So that is the way Solidity works. Solidity only allow us to create a mapping outside a function. So you can't create a mapping inside a function. The only two reference data type that we are allowed to create in a function are both the array and the struct. And we said the only array allowed in a function are just only fixed array, and we look at the syntax for creating a fixed array. Then one thing we need to know about this array that is created within this function is that the pop and the push member is no longer available to this array again. The only member that is available to it is just the length. And since the array is a fixed array, we already know the length of the array, the length which is 4. So there's no so the length which is 4. So now, then to now we want to add value to this array. One way we might try to do it is what? We might say we want to do it via the push member, but as I said, the push member is no longer available. So now the way of adding value to an array that is declaring is a function is you specifying the index of the array. You specify the index, then you add your what? You add your value, which will be one. So everything compile without throwing an error. So now we've looked at how to create a fixed array, how to create an array in a function. We've looked at how to create a fixed array. Then we've looked at how to add a value to an array. Then we've looked at what? We've looked at storage locations. We've looked at um the struct, how to create what? Assigning storage location to it also. Now, a question will arise is that, is it now possible for us to use the storage location for this array again? How to create an array, how to create a local variable array. And we said the only array that is allowed to be created as a local variable are just fixed array. We don't deal with dynamic array. In Solidity, that's basically how it works, and we look at the syntax on how to do that. Then we've also been able to create a mapping, create a assign a value to a struct, and been able to declare a struct as a local variable also. Then we've been able to successfully assign value to it. Then, as I said, we can't declare a mapping inside a function, and because in Solidity, mapping is only allowed to be in storage, and for Solidity, for mapping is only allowed to be declared in the storage. That is why you cannot declare mapping in a function, because you cannot have mapping as a local variable. So, but the only thing you can do now is you can add value to your mapping. Now, let's look at how we can add value to our mapping. Now, we've been able to create our mapping. This our mapping is called student. So now, the way in which we add value to our mapping, since we said mapping is basically a key value pair, then to add value to our mapping, you copy the name of the mapping, and what are the so what will be the key. Then from here you can see the key is an integer, and our value is this struct that we created. Now let's come, we've copied the name, then you copy the name of your mapping. After copying the name of your mapping, then you go down, then so it is a key value pair, and the key is an integer. Then you input any integer you like, and the integer we are dealing with is basically unsigned integer. So unsigned integer are zeros, one, two, three. Unsigned integers are positive numbers. They don't they are always positive. They are not negative. Now obtain. So now we've been able to create the key for our mapping. Then it's time to now obtain our structs that have been created. So now we've been able to successfully create a mapping, and we've been able to store a value in it. So now I want to draw attention to something that is very important. Now, if you look at when we're declaring variable, don't forget I said variables that are declared inside a function, they are regarded as local variable. Now if you realize, when we were declaring local variable that fall under the reference type category, you realize that we were creating storage locations for this variable. Now let's now try to create a the variable that fall under the value type as a local variable in a function. And example of variable that fall under the value type are uint. So, and we said uint are what? Uint are unsigned integers, that is, they are positive numbers like zeros, one, two, and three. So now let's create an integer uint, and age 34, and is equal to 6. You realize that this this variable that we just created, we were able to successfully create it in a function without assigning a storage location. So now, the way Solidity works is, if you are creating variables that fall under the value type, if you are creating them as a local variable, or you are creating them as a variable in a function, you don't need to tell Solidity their storage location. Solidity itself will or Solidity by itself is going to store this type of variable in the memory storage location. So this is where this is where they live in the storage, they live in the storage, they live in they live Solidity will automatically store them in the memory storage location, unlike the reference type variables like array that is declared here. We need to explicitly That is, we need to explicitly tell Solidity where we want to store our reference type, and the only storage location that is available is just what? Is just memory. We are not allowed to store this local variable in the storage location. So let me change the memory to storage. Realize that it threw an error because the only storage location available is the memory. The only storage location that Solidity enables us to store this type of local variable is only the memory. That is only the memory storage location that Solidity made available for us. Now, if you look at the difference, so and I talked about this string and this byte. Although this string and byte they fall under the value type, so under normal circumstance we are not supposed to specify a storage location for them. But now Solidity is telling us now that this string and byte data type, they are a special type of array. So now if they are special type of array, then Solidity, if they are special types of array, then we need to just treat them like an array in if you are using them as a local variable. So let's not get confused. Let's just understand that this is how Solidity works. So it's just how Solidity works. So if you just understand that that is how Solidity works, then understanding or comprehending this will not be that difficult for you. Now let's move further in our in this tutorial. So now let's create a function, name, add name, and let's um let's add our visibility. Visibility is public. So now, and this function is going to accept a variable. Let's name the variable string memory, and just say name. So don't forget again, whenever we are creating a whenever we are creating a reference type variable in an array, or whenever we are creating a local variable that fall under the reference type data type, we need to always specify the storage location in which we want to store them. So, and the reason why, so since array is a it fall under the reference type, then we need to, whenever we are creating array variable, we need to specify where the storage location of that array variable is. And we said string and bytes are like they are special type of array, and array fall under the reference type. So that is why for string we are specifying their storage location. So although the string and byte also fall under although the string and byte fall under the value type, data type. So but just understand that this is how it works. So that is basically why we are specifying the storage location for the string. Now, had it been we decide to change this our string to something like int, then let's just say it. You realize that despite so now we are passing an argument which is named age into this function, but the what type of argument are we passing? The argument is basically what? An unsigned integer which fall under the value type, data type. But now in this case now we are not specifying storage location. As I said, you don't need to specify storage location for variables that fall under the value type. Then Solidity will do its work of storing them in memory. So now variables like this are basically variables that are used as local variable that fall under the value type data type are basically stored in the memory. So Solidity does that automatically itself. And also if you are using the variable that fall under the value type data type in a function, they fall, so you don't need to specify memory and storage location for them. It is only variable that fall under the reference type, data type. Those are the variable in which you will specify your storage location for. Now, let's assume that we are returning function So now, as we said solidity is a statistically typed language. That is, whatever you need to tell solidity the data type, you need to inform solidity of the type of data you want to store in a variable. Now, if we are inputting this age and all this function is doing now is if you are inputting this age and all this function is basically doing is receiving this age and return it, then we also need to tell solidity where this so we also need to tell solidity where this the type of data that will be returned. So to do that, we do that with the help of the returns keyword. So there's difference. The return we are using here is is return without an S, but the one we are actually using here is a return with an S. So that is the difference. So now the returns keyword enables us to inform solidity the type of data that a particular function will return. Now to inform solidity the type of data, all you just do is int, then we've been able to like inform solidity the type of data we want to return. Now, had it been the argument that we are receiving here is is a string, so string, string, and when we are using a string, we need to specify the storage location. So, and let's name it age. Now, if we realize we specify. So now we are returning this string now. Now we now need to tell solidity now because the string are treated as array and this string are basically returned in this function. So solidity also require us that the return we should because the string are treated as array, and don't forget whatever variable that fall under the reference type category. If you are using them in a function, you need to tell solidity in what storage location solidity must store the value. Now, for this return type now, if solidity is also returning data type that fall under the reference type data type, we also need to inform solidity where those return data will be stored. But if the data type that that a function is now in a function, if a function in solidity is returning data type that fall under the value type, we don't need to specify the storage location where that variable will be stored because solidity automatically store it in the memory. But now in our case now, what we are returning an array, and don't forget we said solidity treat an array as and now we are in this case now we are returning a string, and don't forget we said solidity treat a string as an array, and the array an array data type basically fall under the reference type. So now that's why we now need to tell solidity what storage location the this we now need to tell solidity the storage location this data type we are returning should be stored because they fall under the reference type category. Now to now do that, just write your string, then memory. So now we've been able to what successfully tell solidity where it should store the data type data return. So we said we want this data type data return to be stored in memory, and don't forget it is only the memory storage location that solidity made available for us. If you are creating a local variable, it is only the memory storage location. Now let's attempt to change this memory now to storage location. What can you see? It's definitely true an error because Solidity does not allow us to store local variable in storage. The only storage location that is made available for us is the memory storage location. So now let's look at so now we've look so now let's look at a function that the visibility is marked as external, and let's see how they store their data. So now let's create a function and let's name the function add age, and the function, let's say so I would like to draw our attention to just some certain fundamental things that we really need to be aware of. Now, if you see, the visibility of this function here is public, and the visibility of this function here is what is external. So by default, any function that their visibility is external, the default storage location for their argument will be what is called data, will be the core data storage location. Although we can also store their argument in memory, but any function that are marked as any function that their visibility is external, then their default storage location is called data. Then unlike the functions that are marked as public, private, or internal, for this function that are marked as private, public or internal, their default storage location is usually the memory. But also you can still store their argument. You can still store their argument. The default storage location for their argument is usually memory for function that their visibility is either public, internal, or private. But function that their visibility is external, their default storage location for their argument is usually the memory. So now let's keep that in mind. But if we can also change it, if we can also change it to, we already said their default storage location is what is called data. We said their default storage location is called data, while function that are marked as function that their visibility is either public, internal, or private, their default storage location is usually what is usually the memory. So and also function that are marked as public, internal, or private, the default storage location for their return type is also memory also. But also we can also store the return type in a core data. So let's just take note of this. So now, as I said, the for function that their visibility is marked as public, private, or internal, the default storage location where they store their arguments and return type are usually memory. But function that their visibility is marked as external, the default location where they store their data is the core data, but their return type can but for their return type is usually memory. So now, because this function is marked as public, because this function now is the visibility is public, now our return type is currently stored in memory. We can also store this data in called data. Now, if you realize it is definitely true an error, because in the function argument here, the storage location in which we specify for this particular argument here is memory. Now we are now putting what core data here. Then to fix the error, just change the memory to what? The memory to core data. Then everything will work successfully without it throwing an error. Now I also want to draw our attention to something. I also want to draw our attention to how when we are assigning data that is stored in memory, when we are assigning them to data that is stored in the storage location, and when we are assigning data that is stored in in the memory location if you are assigning them to data that are stored in the what in the storage location. I want to explain how these various data, I want to explain how they behave. Now let's create a function. Now as I said any variable that are outside the function, those type of variable are regarded as what are regarded as state variable. And for this type of variable, their default storage location is what their default storage location is usually in the storage location itself. So this variable, they live in the storage location, that is they are directly stored on a blockchain. And for this kind of variable, you cannot specify and for this kind of variable, you cannot specify a storage location for them. So Solidity, Solidity automatically know where to store this type of data. Now let me show you what I'm saying. When you are creating an array within a function, you need to tell. So when you are creating an array within a function, and as I said, any variable that are created inside a function are simply regarded as what? They are simply regarded as what? As local variable. Now let me copy this array. Let me copy this array, then let me do some modifications on it. Let me change the name to num, and I think that is all. Then let me specify a storage location. What you see here now is Solidity is string an error that we are specifying. We are specifying a storage location because any variable that is classified under the state variable category, they are directly stored in the storage. So you don't need to tell Solidity where to store it. So it know where to store it itself. It store it in the storage location. Now now we now have, as I said, this state variable, they are stored in a storage location. And now let's now look at how variable stored in the storage location and variable stored in the memory location. Let's look at how this variable interact. Now let me create a state variable. Let me create a state variable named what? Abby. Then let me declare the visibility as what? As public, and let me to initialize it to 1. Then let me create another variable. So let me create a function. So let me create a function. Function name check interaction. And during, as I said, whenever we are declaring variables that fall under the value type category, whenever we are passing them or using them as a local variable, you don't need to specify the storage location for them. The only variable in which you specify storage location for are variable that fall under the reference type category. So those are the variable you specify storage location for. So if the variables that we are using fall under the value type category, then Solidity defaultly store them in the memory location. And we've looked at the memory location. We said the storage location is just a temporary place where data are being stored, and data stored in it can be modified. While we said the core data storage location are temporary storage location in which the data that are stored in them cannot be modified. So now what we want to do is, now since variables are stored in different storage location, we have some variables that are stored in the storage location, we have some variables that are stored in the memory location. Then now what we want to do now, we want to see how these various variables, how they would interact with each other. So that is what we want to look at now. So now let's name our argument as st. Then let's declare our visibility also. Then let's input our two brackets and let's see how it works. Now currently, now this argument is what is. So now let's just create a function. let me declare a local variable here. Now, you is equal to a Steve, and let me assign. So now the variable that we created is what is Ade. So now don't forget this Ade variable, this variable that is named Ade is a state variable. That is, they are variables that are stored in the storage location. And when a variable is stored in storage location, they are persistent, they are permanently stored. They can't be deleted. They are permanently stored. Now we want to assign this variable that is currently in the storage location to this variable this variable that is currently in the memory storage location. Don't forget, whenever any variable that fall under the value type category, and when they are used as a local variable, then when I say local variable, I said local variable are variable that are declared within the function. When this variable are used as a local variable, the storage location in which Solidity store them is the memory storage location. But we cannot explicitly tell Solidity that we want to store them in storage. So if we explicitly tell Solidity that we want to store this type of variable in the storage location, Solidity will throw an error. But just be aware that where Solidity store local variable that fall under the value type category is in the memory. Now we've been able to assign this variable name Ade to this variable name Steve that is currently in the memory location. Now happen, something an event have take place here. So now Steve is currently in the memory storage location while Ade is what in the storage location. What now happen? Basically, now at the process of assigning this variable name Ade to this Steve, then this Ade variable was automatically copied to the memory storage location, so that we will make the variable so that we will make it the value of this Ade variable available to this Steve that is in the memory storage location. So now let me explain. Let me explain again. We said this Ade variable is stored in the storage location, is currently in the storage location. Now, and the variable that we declared inside this function, they are basically what? They are stored in the memory location. They are stored in the what? This variable now, this variable named Steve that is declared inside this function, they are stored in the memory location. So now we are now assigning variable name Ade that is stored in the storage location to a variable named Steve that is in the memory location. So now if we are assigning a variable stored in the storage location to a variable that is stored in the memory location, so what automatically happen is the values of that variable that is in storage location is automatically copied to the memory location, so that the variable will be available for this for so that the variable will be available for this variable named Steve that is what that is in that is the variable will be available for this variable named Steve that is currently in the memory location. So now, we've been able to successfully look at how this type of variable behave. So now let's look at another scenario. Let's say we declare another variable here, and let's say we declare another variable let's declare another variable. Let's name it length public due date. Let's name it due date. So now let's declare the variable date. So let's declare the variable without initializing it. So now, and we said that we don't have concept of null or undefined in Solidity. So now, as we declare this date variable now, this date variable automatically have a default value that is assigned to it, and the default value that Solidity assigned to variable like integers is 0. So now let me copy this and go back to. So now Now let's assume that we also create another variable. Um, delete it, showing some errors. So now let's create another variable named int my age is equal to my age is equal to 33. Then I'm now assigning this variable to this date that we created in the storage location. So now what happens? What will now happen is, so now look at the relationship again. This date variable here has been created at the top, and so this variable date is a what? Is a state variable. That is, their variables, state variables are stored in the storage location. Now I'm copying this variable. I'm now assigning this variable name my age, and this my age is a local variable. That is, so this my age is a local variable, and we said local variable will be stored in the memory storage location. So what is now taking place here now is we are assigning a local variable that is stored in the what? In the memory storage location to a variable that is stored in the storage location. So now for Solidity to make the value of this my age variable that is currently in the memory location to be available for the date that is currently in the storage location. So what just happened is Solidity will copy the value of this my age that is currently in this storage location, then copy it down to the storage location so that this my age value will be available for this what? For this the date variable. So now we've basically look at how this how data that are stored in different storage location, how they interact with one another when they are assigned to each other. So now let's now look at how data that are stored in the same storage location, let's look at how they interact. So now the first storage location we look at are memory memory storage location and storage memory storage location and normal and storage location. Now let's look at the relationship between memory 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 storage location and what? And memory memory storage location. Now let's declare another function. And let's name the function validate. Another function and let's name it validate. Then let's add our visibility and let's add our bracket. So now let's create a so now inside this function now let's create a local variable. So now we have uint and our uint to be active, then we are assigning 3. Then and don't forget, whatever local variable are stored in the memory location, variable that fall under the value type data type category, you don't need to specify their storage location. The only variable in which you specify their storage location are variable that fall under the reference type category. So currently now this variable we are having here, it fall under the value type category. That is why we are not specifying their storage location. So because Solidity will automatically store them store this variable to the memory storage location. So this variable cannot be stored in the storage location. Solidity, only variable that are meant to be persistent, or variable that are meant to be persistent, that variables that we require to be permanent, those are the variables that are stored in the storage location. But whatever variable that is using inside the function, those variables, we don't want them to be persistent. So that is why these variables are always stored in the memory storage location. So now we've created a memory variable. Then let's create another memory variable, and let's create another memory variable, and let's name it just give it some random name. Let's say hello. So now let's now assign this steve to this let's assign this steve variable to this hello. Now what happened here is, now we are looking at the relationship, how the variables how two variables that are in the same storage location, how they react. Like now, for example, we are looking at the memory storage, how memory storage location vari- how two variables that are stored in the memory storage location, how they interact. Now we've created this hello variable is currently in the memory storage location, and this second value here, this hello is currently in the memory storage location. Then this st variable also is also in the memory storage location. And when we created this st variable, what we did is we initialize this with the value of 3. Then we now update this hello variable. We update it with this st variable. We update it with this st variable. So now what typically happen is that when two variables are in the same storage location and you assign one variable to another, in this case now we are assigning the st variable to the hello variable. So what basically happen is that it is a reference to where that variable is stored that will be given to the variable in which you are assigning the other variable to. So let me explain. Now we have this, we've created this hello variable now, and we've created this st variable. So now we are currently assigning this st variable to this hello variable. So now what Solidity does is, instead of copying the value, Solidity will not copy the value. It is the reference to the storage location of this st variable where it's storing the value, the reference to its storage location, that will be passed down to this hello variable here. So now any attempt for us to now use this hello variable, what Solidity will just, any attempt for us to now need the variable, then Solidity will then look up the storage location, the we said it will give us a reference to where this st store its value. Then when this st is now assigned to this hello variable, what happen here is, what is actually assigned to this hello variable is the reference to this st variable. So now anytime we now need the hello variable, then Solidity will automatically use that reference to obtain the rightful value. So this is how variables that are living in the same storage location, this is how they actually work. Now, so we also have a lot of we also have some other relationship. Now let's also look at storage location. So let's look at storage relationship now. So if two variables that are in the same, let's say if we have two variables that are living in the, so we said we have storage location. That is, we have memory storage location, we have the data, we have the core data storage location. We also have storage location. So now if we have storage 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 data location, So two variables that are in the storage memory storage location. That is, now if we have two variables, if we declare unit a, let me say unit xyz is equal to what, is equal to 56, and we now declare another variable unit tsx is equal to, so we just declare this variable initializing initializing it. So now how does this variable behave? So now if we decide to now assign this xyz variable, if we decide to what, if we decide to um if we decide to assign this variable, why am I getting an error? Okay, so let's assume now that we've created these two state variables, txx and xyz. So we've created these two variables. Then let's go down to our function. Then so now we've created these two variables. Then what we now do here is we decide to what, assign this xyz variable to this tsx variable. Now the way Solidity works now is, although these two variables are in the same storage location, then what Solidity will then do is, when this xyz variable is assigned to this tss variable, is Solidity will now create an independent copy of the value of this xyz variable, will now create an independent copy for this tss variable. So now making this tss variable break away from this what, xyz variable. That is the tss variable and the xyz variable are both, they are independent variable, they are not dependent each other, they are not referencing each other, unlike the way the memory storage location, unlike the way they work. Because the reason being that if two if two state variables are assigned to one another, what will happen is that Solidity will create an independent copy of one of those variable, then assign it to one another. In our case now, you see that we have two independent variable. The two independent variable we have is txx and xyz. So now these two independent variable are both in the what? Are both in the storage location. Then we now decided to assign the xyz variable to the tsx variable. So what Solidity does is, Solidity will create an independent copy of this xyz variable, then assign it to the what? To the tss variable. Now let's now look at another relationship. So guys, we've literally been learning a lot. We've looked at the remix ID, we've looked at how to tell the license of our code, how to tell the Solidity compiler, the Solidity version we're interested in. We've looked at the various data type, we look at the value type, look at the reference type, then we also look at categorization of variable based on their feasibility. We look at the state variable, we look at the local variable, we look at modifiers, we look at visibility. So we've literally done a lot of things. So this is where we'll be rounding up to this lecture. So now let's also ensure that we also do a personal reading. So because you might not get everything from this tutorial, but at least the tutorial should be able to take you to a point where you yourself you can stand on your own and start building and improving yourself. Have a wonderful day. Enjoy the rest of your day. Bye for now.